Hi everyone, welcome to this week's webinar going over heavy industrial. I am Savannah Priest, the Inside Sales Manager over here at MOBOTIX. I'm going to be monitoring any questions that you may have, so feel free to leave any questions in the question box down below. Kurt Dow, our Business Development Manager, will be the host of this meeting, so I'll go ahead and pass it over to Kurt to introduce himself.
Hey, thank you, Savannah. Thanks for the introduction. My name's Kurt Dow. I'm the Business Development Manager for the South Central United States, and I am joined today by JP Kochar, who is with MOBOTIX. He is our technical project engineer that covers the Central and the West. I'm also accompanied by Michael Sunrise with Remote Monitoring Technologies out of the Dallas-Fort Worth area. Michael is a longtime MOBOTIX partner, and so I wanted him to join today because a lot of the information that we're going to talk about across different industries, Michael's had his hands in, and so we're going to have a roundtable towards the end, but I'm going to go ahead and start. I'm going to stop sharing my webcam for now and go ahead and get going. So I'm going to cover some things today that many of you already know about MOBOTIX. However, we do have new partners and end users that are on the webinar with us. So please oblige me as I cover some things that you may already know. But the MOBOTIX DNA, the building blocks of MOBOTIX, are what makes our products unique and special in the market. You've heard and will hear us continue to talk about the MOBOTIX DNA. MOBOTIX made the first true smart device back in 1999. Think about that. In 1999, MOBOTIX had the foresight to come out with a product that was a true edge device, and this was long before the term IoT ever existed. The decentralized concept was revolutionary at that time and has proven to be the right move for us as a company. We are an IoT edge device, or a computer that sits at the edge that you can put any combination of sensors on. Thermal, which will be a lot of our focus today, as well as optical, illumination, decibel levels, and the list goes on and on. With dual sensors, two-way audio, onboard analytics, integrated storage, lip synchronous audio, low light technology, and I can go on and feature you to death. The point is that because this is a computer at the edge, we do not need additional hardware and software to make these types of solutions work. As an additional note, many of you may know, some of you may not, that MOBOTIX was the pioneer of the hemispheric or the fisheye technology. Big deal, right? Everybody has it today. That's correct, but MOBOTIX was the pioneer and has pioneered over 40 patents, and we're not slowing down. It's also really important to note our commitment to be the leader in security. Since all of our R&D and hardware, software development, design, and production happens in Germany, we control that process from start to finish. A main component in our Cactus concept, or our cybersecurity concept, is the fact that we are decentralized. Again, meaning that processing, analysis, storage, it's all carried out on the camera itself. It's encrypted and controlled by the camera. This offers system-dependent protection against data loss to third parties. We have developed a unique concept for the reliable and complete protection of end-to-end video systems against hacker attacks. If you guys are reading the news today, you know that there are a lot of hacker attacks against our competitors. So we are very proud of this, but we're constantly having penetration testing conducted to ensure that we're best in class. So you can rest assured you're deploying the most secure systems. A question we get a lot is, are you NDAA compliant? And the answer to that question is 100% absolutely. I love this slide because it really hammers home a couple of points. Not only are we staying current by providing updated security patches, but we're doing this for cameras back to 2004, which is the second point on MOBOTIX durability, which you're going to see a great example of later on in this webinar. But we all know this is a solid state device with no moving parts, mean time between failure of over 9 years. But this shows we still have cameras deployed that are 16 years old and older. That's pretty cool in my opinion. And we're designed to work in the harshest of conditions, which makes us perfect for heavy industrial applications. A few other key things to know, and I'll just mention each quickly. We do have a SIP client, so a phone server in our system, microphone speaker. We act as a virtual PLC. It's very modular in design, so if you need to add additional cameras, you just add cameras. You don't need a lot of additional hardware. Solid state, we already talked about. Low power draw. This is another thing that we'll touch on a little bit later, but depending upon the configuration, 4 to 8 amps is what you're looking at. So perfect for remote type of locations. All the analytics are on board, and we've already covered the decentralized portion of this. So we offer our thermal and optical products in a variety of different form factors. Most are still opting for our 6 series here, which has been our workhorse. And I'm talking primarily in the thermal space right now. Whether these are being used in heavy industrial applications or more recently for human body temperature detection, the 6 series has grown tremendously with thermal because of its flexibility and thermal radiometry. And I'm going to discuss thermal radiometry here in a second. But the M16, which you see here on the left, and the S16, S is in Sam, which you see here on the right, they provide a lot of flexibility depending on the solution you choose to deploy. Both solutions provide you with thermal radiometry with varying camera angles from 17 degrees to 45 degrees. Basically, these are the exact same camera with just different mounting options. These are fixed looking forward. These can be pointed in any different direction. Moving on to our 7 series of thermal products, these are starting to gain a good amount of traction. The true difference between the 7 series thermal and the 6 is that the 7 series, you have the option of VGA over SIF. Both are still 50 millikelvin. However, the VGA gives better clarity in images or of images. The 7 series thermal is also available up to a 90-degree angle as opposed to maxing at 45 in the 6 series. You also have more options available regarding analytics, which are on the edge in the 7 series. Even though there are more sensors available in the 7 series today, as you see here, it is important to note out that today it is limited to only 2, a combination of thermal and optical. Okay, the further roadmap is that all of these can be optical and or thermal, but we're just not there yet. But our additional sensors, such as IR illuminators, our multi-sense, these are really good options for nighttime, as well as adding in additional atmospheric sensors. The increased number of pixels and extended image angles up to 90 degrees with the VGA thermal module allow you to see more scene detail and cover larger areas, such as would be important for perimeter protection. But the key to our success with the 6 or 7 series is the thermal radiometry. So thermal radiometry allows us to capture up to 20 different zones in a scene and look for temperature. It doesn't have to always be heat. People think of thermal just as we're looking for heat, but we're just looking for temperature. So when you think through these different applications in the industrial sector, please keep that in mind. One camera with thermal and optical that you can set up to 20 different events that can be configured simultaneously over a temperature range of -40 to 55 degrees Celsius. It's very, very powerful. And not going to spend a lot of time on this, but I did want to show you what the ultra low light in our 7 series, beside our thermal VGA in the 7 series, what this looks like. This is at dusk, very low lux conditions, and you see the brilliance of color over here with the ultra low light, but you can really see the definition in detail with the VGA as opposed to SIF. So jumping into the meat of what I wanted to share today is opportunities in heavy industrial. even through COVID, I have seen a steady increase in interest in business across the verticals that I have listed here. It's not limited to the verticals I have listed here, but this is what I wanted to highlight today. Sure, there was a small hiccup during COVID, just as everybody felt, but these are all industries that powered through COVID because they had to. Oil and gas, I think, took a bigger hit during COVID than these others, just because we weren't using the amount of fuel, jet fuel, et cetera, that we had been using. But oil and gas has been a primary concern of mine over the past few years, primarily because of my location in Texas and the fact that I cover Oklahoma, Colorado, Louisiana, which are all prime oil and gas areas. But the automotive industry is an interesting one as well, as many of these others are. I'm going to spend some time today on oil and gas, wood manufacturing, steel mills, and poly extrusion, because these are all real examples that I have over the past few years. Some of these I'm not allowed to show pictures of inside the plants due to NDAs, and for those I will focus more on the process involved and kind of where we fit. But the automotive industry, as I said, is an interesting one. We have a major manufacturer in San Antonio, and we're in their plants in different areas, but primarily in the paint booths. So this isn't a single booth that, you know, a car or truck comes in and they spray. We're talking a 3-story process of start to finish with this paint. It's just a huge area and a lot going on. And the question was raised to me, can MOBOTIX determine if there is a paint defect before this comes off the line? And my response was, well, heck, I don't know. I'm not a paint expert, right? But, you know, in talking and thinking through this with the customer, you know, it was determined that, you know, what we can do is show you hot spots, cold spots, and as these come off the line, you know where the paint defects are. We can go back and look at the video and see if there's a correlation. And they had the prime area where the vehicle would come in on a turntable and turn 360 degrees. So we put a thermal camera in that area, and sure enough, over about 3 months of testing, it became very clear that you can see defects because they show up as hot spots and cold spots. This was a multi-million-dollar problem for this facility and for many other facilities that we were able to solve with a relatively inexpensive solution for them. That's just one example of what we're talking about when we talk about heavy industrial opportunity. So I'm going to spend just a few minutes talking about oil and gas here. So in oil and gas, I really started with just the monitoring of flare stacks. We would have a thermal camera fixed on the stack, not attached to it, but looking at it, and notifications if the stack or flare goes out. You know, one minute we're seeing a certain temperature, the next minute we're not. It was very interesting because it really depends on how far back you are, how high up you are, and there's a lot of atmospheric conditions that are between the thermal sensor and what we're monitoring. So those things all affect what we're reading. I think at the initial site I was at, we were reading about 400 degrees, but we were a considerable distance away from the flare stack. And these guys are saying, well, it's just not working because that thing's burning at 1500 degrees, not 400. So we had to explain thermal is like a campfire. If you're right up on top of it, it's going to feel very, very, very hot. But the further you go back and the more atmospheric conditions you put between yourself and that flame, the cooler it's going to feel. You're going to get a different reading. So once we got through some of those learning curves, we showed them very quickly that as this went down, straight out of the camera, we could notify them that there was an issue. It's pretty simple, but this has large EPA ramifications to it if it's not lit. Their current solution is a thermocouple in the base where the pilot is. However, this is not foolproof, and those things fail frequently. Then you have the production downtime when it's replaced because the stack has to cool. You know, it's not the cost of a thermocouple, it's the downtime that they're missing. Lift pumps have critical moving parts, and the saddle bearings and wrist pins are monitored for wear and overheating. Again, it gets to a certain level, we can do whatever notifications the operator would like. This is more of a preventative maintenance issue. But leaks in lines and tanks can be detected. We're not telling what the gas is, but we're telling if there is a leak, right? There is equipment that'll tell them exactly what type of gas that is. But, you know, you're talking tens of thousands of dollars for a solution like that. And quite honestly, if that's what they're looking for, then this isn't the solution. But for the most of what I've run into, they just want to know, are we having an issue? Is there a leak? And again, that's preventative maintenance, but it's also, we get into those EPA issues. As well, we can give a visual look at what the tank levels are. Is there a separation between oil and water? All very important things. Saltwater disposal is another key EPA issue that we've been successful using a combination of thermal and optical. So the initial thought was, let's use a thermal to be able to show in the containment system if there is a leak. But what happens if it rains? So we had a solution that was good 70% of the time, but now you can use optical to see and track the flow of water as a means to trigger their solutions. So fire suppression. Companies are utilizing thermals, among other things, as a means to trigger their solutions. There's so many opportunities in oil and gas. The key is to get out on operating sites and just ask questions. People like to share what they do, but they all have very expensive problems that, believe it or not, there's not many answers to today. And I'm talking your extremely large oil and gas companies that we all know by name, to the very small operators that are doing just jet fuel, for instance. It doesn't matter. They have the same issues. And you can take that across all the different industries. One that is really big is wood manufacturers. So the oriented strand board, MDF, paper mills. We're going to jump into this in a moment with Michael because he has really deep experience here, but furnaces, hoppers, dryers and inlets, and all different types of pumps are very, very key in this business, and they all fail. They catch on fire. So how can we utilize thermal to solve those issues for them and to prevent, you know, fires, to prevent catastrophic failures before they happen? Again, multi-million-dollar problems that can be solved with a relatively inexpensive solution. Metal and steel extrusion. This is a tremendous opportunity that we're also going to discuss with Michael because he has deep experience here. But to me, a steel mill is the holy grail of utilizing thermal and optical products in combination with one another. Whether they're starting with iron ore or they're processing scrap metal and recycled steel, this entire process is nothing but ovens, furnaces, molten steel, and transporting that through an extremely long process to get to a finished good. So again, we're going to spend a moment on this in just a minute, but I think see what I'm talking about. And one of the ones that I took on, because very early in my business career, I was actually in building materials, and you know, so many of these are extruded products, right? And extrusion is just the process of manufacturing, you know, long products of constant cross section, whether it's rods, sheets, pipes, films, wire, insulative coating, different fibers for carpet, forcing a polymer through a die that has an opening at the other end. The polymers are fed in pellet form through an extruder. It's pushed through a screw. It's heated up so that it melts. You notice that thermocouple again there at the end. Again, they tend to fail just like in with the oil and gas flare stacks. It's lost production time, but the product that's coming out of the die is then cooled either by blown air or it's put into a water bath. It's again, this is a fairly simple process, but it spans so many different industries. Pipes and tubing in for plumbing and different applications, weather stripping, fencing and deck rails, plastic films and bags, shrink wrap, thermoplastic coatings. The carpet industry is a big one, you know, because they extrude fiber out of polypropylene and other things, and that's what they make it with. Vinyl sheet and flooring products, and the list goes on and on. And all of these types of businesses are all throughout North America. I mean, those of us who sit in the South Central, in Texas, Oklahoma, you know, the areas that I laid out before, those are great oil and gas areas. There's a good gas potential in Western PA, Southern California, the Dakotas, Western Canada, Alaska. But you know, you don't have oil and gas everywhere. These types of products are in every major city. So you just got to look for them. You've got to do a little bit of digging and just get in and ask a lot of questions. And the one thing that I wanted to do today is not just have this be a webinar where I'm just preaching and telling you guys everything that I've seen and just run through a slide deck. So that's why I wanted to do more of a round table here. So one of the first slides, though, that I talked about was, you know, MOBOTIX and how rugged and how durable they are. So I'm going to ask Michael a question here. Michael Sunrise with Remote Monitoring. Michael, do you recognize this picture, and can you give us some input around it?
Yeah, thank you. I appreciate you having me on here. And this picture does bring back memories. Back in the beginning of the MOBOTIX thermal era, which is what we call that particular era, when they came out with the thermal camera, we all got really excited about it. One of our clients was a steel mill. And so I went out there and we started talking about the need for thermal and the applications that they and their functions on a daily basis. And one of the problems, one of the concerns, solutions that we had to overcome was the extreme heat environment. Now the cameras are rated to withstand heat up to 140 degrees. But as everybody knows, the steel mill environment is way over that, extreme temperatures. But in order for the thermal to see what it needed to see, we had to develop an enclosure that we could control the environment within. So we developed this dual walled box that we could pump nitrogen in, and it would control the environment inside the box. And so the camera could live in there without having to deal with heat. That was very successful. And I'm going to show you actually when the screen gets turned over to me, I'm going to show you this box as it was manufactured in our facility. I guess that's me now, huh?
Michael, you should have control.
Okay, which monitor do you guys see? You see this? You see the box?
Yes.
Okay, that picture that we showed you earlier was this box. The original box was this box, And the original application was not thermal. It was just to put a camera in the steel mill. So we didn't want it to melt. So when we developed the box that we could put the nitrogen in the dual walls, they came back to us and said, well, can we put a thermal in there? And we were like, well, the problem with that is thermal will not function if it has to look through plastic or glass. You have to have a very specialized lens, a germanium lens. So we developed this box, which is powder coated, extreme environment protected, thick glass wall with a germanium lens in the cover. That thing was great. It worked out fantastic. The problem we ran into was they wanted to put it closer and closer to the charge. It's called the charge, when they stick all the metal into a big bucket and charge it up with electricity and melt the metal. That also comes with its own hazards, and that hazard, one of those hazards, is splashing liquid molten metal. And that last scene, that last view you had of that camera, that box, is this thing getting splashed by 3,000-degree molten metal and burning the box and just completely destroying the face of the camera. And so we took the camera and the box, took it upstairs to the electrician's office there in the mill. And I said, let's plug it in and see what happens. So we plugged it in, and there's actually literally a video of us waving on a monitor behind the box because the camera still functioned. And I could not believe it. We chipped off the front of the stuff that melted on the lens and on the sensors and turned it on, and it still worked. And to this day, that camera still works. It's been on a road trip for a couple of years now. It gets passed around from distributor to distributor as a witness to how durable that box and how that camera is. And that's what we like to tout, how the durability of the robotics solution. That's one of the reasons why they'll offer up to a 6-year warranty on these cameras, because of the durability and extreme environment capability.
So Michael, was that an M15?
Yeah, it was an M15 Thermal with a 079 lens in it, and the same thing you're looking at right here. This is the box, and that we showed earlier. So we're pretty proud of being part of the MOBOTIX environment and part of the MOBOTIX family. Whenever we have an issue that we need a solution for, we go directly to MOBOTIX and see what their product line can support us with on dealing with that solution. And we've been a well-known integrator in their environment for many years now. And that's why Kurt has asked me to come on here. We specialize at this moment in thermals. We have thousands of thermal cameras out all over the country. And I wanted to give you guys a couple of views and a couple of applications and some ways that you might consider approaching your clients, or if there's end users out there, any questions, maybe you can, maybe some of those will be answered here.
Yeah, well, Michael, honestly, that's one of the reasons why I wanted you to be on today, because not only do you guys have all those thermals out there, but you've been the guy that's been out there putting them up, selling them and putting them in, right? So in keeping with the steel mill train of thought though, man, that's a big elephant to bite off, right? I mean, because these are just behemoth type of operations. Can you explain how you got your foot in the door and just what has transpired since that time? Just walk us through that, because it does look like a lot to bite off.
Yeah, we did a large school installation, and the IT guy at that school installation had a friend who was a head electrician at a steel mill here in the Dallas-Fort Worth area. And they were looking for a solution to something that was durable enough to handle the environment that was out there. This is before the thermal came around. So we went out there with one camera. It was an M16 dual lens camera, and we set it up next to a competitor's camera. And they were able to take a look at it. As soon as we turned it on, it was evident that the quality of the image, the features that were available to you to be able to analyze the stuff that was going on within that image was head and shoulders above the competitor's camera system. And as that view got passed around the plant, all of a sudden, the next thing you know, there's other areas of the plant that are asking for that view or something along those lines, so that they could use it in their particular area. That propagated out over the course of 3 or 4 or 5 years into 700 or 800 cameras on that particular plant, and their other plants in other areas of the country started to approach us, and that's how that particular client grew. To this day, they still call us. Matter of fact, they've got to the point now where they've decided that they have this stuff in their SAP system. They just keep it stored on their shelves, and whenever they need a refill on the shelf stock, they just get a hold of us and we ship them the cameras. That's an excellent example of how you can grow your client from one camera all the way to now they stock them on the shelf. And it's an order taking situation.
And this is kind of a baited question because I get this a lot, right? But how did you progress from that one camera? Because the biggest challenge is to take it from one department to the next to the next. And it doesn't matter if you're in a steel mill or let's go to the automotive manufacturing that I talked about earlier, you know, taking it from the paint booth to another area. How were you able to do that and progress it through the different departments?
There's initial sales resistance in everything that you do as far as sales is concerned, and the best way to overcome that is to build relationships. As you start to build the relationships with the particular client that you put that one camera in there with, and they're happy because they made a decision that's going to be beneficial to the company, they're going to start talking about it. And once they start talking about it, all you got to do is follow up with and be available. Just be available to follow up, answer their questions. You know, don't be condescending about because you expect them to know the answer, because it's you know the answer. Always be in a position to be open to helping them try to achieve what they're trying to achieve. Usually it's a solution that they're looking for because they haven't been able to find it somewhere else, or it's been inadequate. And if you can come up with a way to address that solution so it takes that headache off their agenda, then that's the way that you end up moving from department to department to department. And the next thing you know, you're talking to the upper management, and then the next thing you know, there's a mandate that goes out that says all new cameras are going to be robotics, or you know, all new work is going to be to RMT. So that's one of the ways that we went about doing it, and that's basically how this happened at this particular mill.
Well, and I love this story because I was involved at the beginning as well, but it's just starting with one camera, and now there's close to 1,000, and we're talking a lot of thermals, right? So we're not talking, you know, 1,000 indoor cameras. We're talking, you know, a good majority of those are thermals. But it doesn't have to be. When we talk about a steel mill, I mean, this is a great story. That's why I wanted to bring it up. But in this industry, there's many different aspects to it, right? You have companies that do nothing but crush the aspects to it, right? You have chemicals, right, and get down to you know, using that as scrap metal. And so you start there. Now, this particular operation, they do it from start to finish. But I'm just saying, depending upon what your business model is and you know, what you want to bite off, there's different levels of entry, I guess is the best way to say it when we're discussing this. So, Michael, can you give us some examples of typical applications that you're doing in the steel mill industry?
Yeah, the steel mill industry has a variety of different use cases for this particular product. Everything from the charge stations that we talked about earlier, in the way that they develop the molten steel and their processes to do that, all the way through the rollout process and the cutting process and the storage process. Those are all heat related issues that need to be monitored. So the whole idea of developing a steel product is just loaded with opportunities in the whole process. And I think one of the slides that you showed a little bit earlier when it was showing the arrows of going from one spot to another during that process, that's a pretty good example of what's up here. And you got to remember that each one of those processes has a group of people that make a decision and have a budget. So once you have a a thermal camera in the charge area or on one of the rollout stations, then when it hits the cutting station, those guys know that they have the ability to make a decision concerning a purchase within their own budget. Then they'll start looking for reasons or ways that they can streamline efficiency by using a camera like this, and then they'll make sure that they have the budgetary means in order to make that purchase. You really have to be open to developing relationships in different areas of the facility. And once you do that, once your name gets passed around, people will start calling you that you haven't had a chance to make it over there yet. To be quite honest with you, Kurt, this steel mill opportunity, it took 4 or 5 years to get to everything because it's such a huge deal. And not only are we in the thermal aspects of it, but we're also in the optical aspects of it. We have cameras on their parking lots, cameras on their loading and unloading stations and their strapping stations and their scales. And one of the things that we loved about MOBOTIX was you could stream serial data across the screen. So when a truck pulls up, you've got a visual of what's on the truck, and you've also got a visual of how much it weighs, and any other data that you want to stream across the view is there for you, and it's archived and searchable by Management Center.
Yeah, that's an awesome point. And you brought up one thing, and I want to jump into the wood manufacturing because I think that's a huge opportunity. But you mentioned budgets, right? So similar in oil and gas, well, two things there to kind of unpack. Budgets and relationships. And one point I want to make about oil and gas, and I mentioned you really got to be on site, like you're talking about, Michael, and asking a lot of questions and developing a relationship. That's critically important. But secondly, budgets. One thing that I find at the end of budgetary years, whether they're on a fiscal calendar or a regular calendar, sometimes there's budget at the end of the year. Do you find these guys will come to you and say, hey, we found a little more money, so we want to beef up certain areas that might not have been in the original budget?
That's a good point, and one we didn't pre-talk about, but it's an excellent point. The steel mill is an example. Every year at the end of the budget year, I get a call from the electrician saying, I've got so much money left over. I'd really like to go ahead and stockpile a couple of these things on the shelf, or I've got a couple of applications that I want to go ahead and get done out here. So we see that extra money being spent because use it or lose it mentality. And also, as soon as the clock clicks over to the new budget year, right then they're like, okay, I've got a bunch more money. Let's go ahead and start spending it. So budget end of the year and budget beginning of the year are two excellent times to go back to your client and start talking to them about using that extra money to beef up their particular system. And we do that all the time. That's actually one of our sales directives to our sales team is keep an eye on that budget year, because
right,
there's a lot of fruit on low-hanging fruit on the tree. I've got
well,
this. Go ahead.
I have a budget year ending, so anybody needing cameras, you can jump on that as well. Well, I want to jump in, Michael, if you're good with it, and talk about the wood industry, because I know that's an area where you personally and your company have spent a lot of time and been very successful. So let's talk about that a little bit. What makes MOBOTIX the best solution, in your opinion, in that industry? And I guess what are some of the typical applications?
Yeah, the MOBOTIX camera, for one, it handles extreme environments quite well. The wood industry, the crazy thing about these two particular verticals is the heat that's involved in manufacturing a lot of this stuff. And it's not just the heat of the actual stuff getting pressed together or getting cut. There's heat coming from the pumps, there's heat coming from the conveyor systems, the bearings, anything that's moving has friction involved. The whole idea behind putting a thermal camera on it is so that you can get out in front of any issues and be proactive versus having to react to something that's already happened and then deal with the downtime. Downtime is the devil when it comes to these plants, because downtime is money that they lose. It's off the bottom line. So they'll do anything and spend pretty much any amount of money in order to keep them going down. And that's kind of the thought process that we use when we go into these places, and that's also a great sales point. You know, try to determine how much it's going to cost them to be down for a day versus how much it's going to cost them to put this system in, which is going to keep them from going.
Right.
And so in the wood manufacturing industry, we have a great story that we worked with MOBOTIX directly. They had a request for some information. They asked us to take that request and run with it, and we have. And over the course of, you know, the last 4 years, about right, Kurt, we've developed our relationship with the wood manufacturing industry, and they turn to us and MOBOTIX thermals over other thermal options for a multitude of reasons. One of them is there's nothing else out there that has an optical lens that it comes with the thermal camera. That right there is an incredible opportunity for sales, because the thermal camera, it's cool to look at. It's got all kinds of cool colors and stuff, but the human eye doesn't actually see the detail. It just sees where it's going to be hot, right? This is why I pulled this particular picture up. It's really an incredible image. The camera has the capability of taking the optical lens and the thermal lens and actually doing an overlay. So as you can see here, the camera has two sensors. That's what the thermal lens sees, and this is what the optical lens sees. Wouldn't it be nice to be able to overlay that on top of the optical sensor so you know exactly where the hot spot is, and you can use it as a relative point of reference? And that's what they did here. So this particular overlay could be cleaned up a little bit, but it's rather close. You have the capability of actually getting it exact with the algorithms that are built into the camera. So this is an option that they loved. This killed two birds with one stone. And we were able to propagate this out through all of the pumping systems and facilities. So that's a pretty cool application.
Yeah, it looks like a sales guy did that, not an engineer, right? I'm just giving you a hard time. You know, one of the things you mentioned that just spurred a thought in my mind, which happens occasionally. You know, what does make MOBOTIX the best solution in this? You know, Michael, you talked about the thermal and the optical. I talked about thermal radiometry earlier, which is fairly unique to MOBOTIX because there's another company that provides this, but you got to get into their handheld test and measurement equipment, and we're talking 20,000 and above, right? Pricing, we are very competitively priced. You know, most people know MOBOTIX as being one of the higher priced products in the market, but not when it comes to thermal. So that's something to keep in mind. And today, it's availability. You know, a lot of people today I'm hearing are quoting 12 to 14 week lead time. We know we have this semiconductor chip shortage and whatnot, but at MOBOTIX, we're actually in a position of power right now when it comes to thermal. And the reason is we built so much thermal inventory, elevated body temperature and everything that we were doing there, and then vaccines came out and things just slowed down a little bit. So, you know, I have people calling me that I've been talking to for 36 months about MOBOTIX thermal that are using the name brand competitor, and they're coming back to me saying, hey, we want to talk now because we can't wait 14 weeks till we get that product. So those are really things to keep in mind, especially right now. We are in a good inventory position, not just on thermal, but also on optical, but it is tightening up. And it's not just the semiconductor shortages, there's ports that are being shut down, the whole supply chain's being interrupted right now. So, you know, I'm saying today we're in a really good position. 3 weeks from now, it might be a different conversation, but I thought that was important to get out here. So, Michael, how did you actually break in? Here's a question that came from one of our folks online. How did you actually break in to this business?
Well, each client has its own story. To give you an idea of how we got into the steel mill, I think I mentioned that before. It was a friend of a friend that was working there. The wood manufacturing company that we deal with, or the wood manufacturing companies that we deal with, was initiated through a telephone call from Robotics that somebody approached them for a lead. Almost all of our clients come from our website, which you've seen. We've advanced our website to update it so that it captures, leads. And also, it's kind of crazy, but if you pick a vertical and you go out and you find a solution to an issue, they start talking about it. The next thing you know, we've got 4 or 5 companies within that vertical that we're handling and helping them, streamline their operations and become efficient doing what they do. So it's just a sales process. It's just being relationship building, and breaking into it is nothing more than trying to stick your foot in the door, push the door open. Basically, it's the same thing with new sales opportunity. Just get good. You got to get good at what you do. You got to be a master at your craft.
Yeah, and that's a great point, because there's another industry, the chicken industry, right? Which kind of sounds silly, but I mean, we've got one that's a major manufacturer from hatchery to finished product, and the word gets out, and now the other large players in that industry, and we're talking billion-dollar companies, right? I mean, large opportunities are now picking up the phone and calling and wanting to talk about it. So we do have a question here, and I'll throw this one to JP, since he's been very quiet. It's just been you and I talking, Michael. And how different is the web interface with thermal and the optical? JP, are you still here?
Yeah, man. Yep.
Okay, let me change over, see if I can change over to you here. Let me.
Do I need to give up control or something, or you can handle that?
I believe I can do it.
Okay, stop showing my screen.
JP, you should. Yeah, JP, you should have control.
Okay. So are you guys able to see the screen?
Got it. We see you.
Okay, perfect. Yeah. So the interface is pretty much same. It's not really different. There are a couple of actually sections that have been added. So for the thermal camera that I have set up over here, if you go into the setup menu, there are a few settings under the link for the thermal sensor settings. And this is something that you will see only on the thermal cameras. You won't see this link available on your regular optical cameras. And within this thermal sensor settings, you have different options. So you have the option for thermal overlay, where you can actually, which is what Michael showed you, you can actually go in and configure the opacity. You can actually line it up with the actual image, the optical image, and of course you can select your color palette. You have the ability to grab the raw thermal data. So that data can actually be included in your recordings as a zlib file. Again, aesthetic wise, you have color palettes. You can switch between different color palettes for your thermal sensor. There is a temperature compensation and linear mode typically used for very, very accurate and down to like the decimal temperature detection. And again, the temperature compensation over here is used for calibrating the camera to detect a heat source, again, based on how far the camera is, what the environment is. So typically what you're trying to capture, so if it's a human temperature that you're trying to capture, object emissivity comes into play, atmospheric transmission, and of course ambient temperature. So all of these things have to be calibrated very carefully and very accurately, so that you're pinpointing the exact temperature of what you're trying to measure. Again, value range over here, you can set it to small sensitivity, high sensitivity, and of course you can set up the update speeds for these detections. How do you actually go about setting up the detection zone? So it's again an environment event. So you will go to the event overview section, and over here under the environment events, you can see I already have a few of these set up. Let me just move this a little to the left.
So there's that thermal radiometry that we talked about earlier.
Yeah, so what you're seeing over here on this screen is actually the thermal sensor with the TR, or thermal radiometry. And I actually have 5 zones or 5 regions of interest that I've set up. And based on the criteria for each one, it's detecting temperature above a certain value, below a certain value. It's detecting temperature within a range, outside of range. And over here, it's detecting temperature based on a percentage area. So I'm going to quickly run through those typical scenarios that you would expect to set up. So if I hit the edit button, and let's look at above temperature. So over here, I've selected the thermal radiometry as the option for my sensor type, and I have a measurement area. So the measurement area for this one actually corresponds to this window on the top. And essentially over here, you are measuring absolute temperature. So you're looking for the absolute temperature within this window. You also have an option for reference temperature, where you actually draw a reference area, and corresponding to that, the camera will look for the temperature within your region of interest. But most cases, absolute temperature works well. And you have the ability over here to actually measure down to the pixels. So you can go down to 1 pixel. And if you can see over here, this is the crosshair for the hottest pixel within this one window. So I've defined it over here, but I can also go in and set up a percentage, which I'll show you guys later. And then over here, you're looking for a thermal level as opposed to a thermal range. So a thermal range would be within a certain high temperature and a low temperature value. But for a thermal level, you can actually go with degrees centigrade or Fahrenheit, and you can define what value you want. And you can say, okay, above a certain value or below a certain value of temperature is what you're trying to detect. Over here, you have the ability for an offset correction also. So again, this applies only for if you have like an external calibration source, such as a black body radiator. You can actually use that for reference and use it for detecting the temperature. Again, you draw the reference area, which would be a window over the black body radiator within the screen of the, or within the view of the thermal sensor. And then you want to make sure that, okay, you're triggering on every event or every change in temperature that's being captured. And of course, these are some aesthetics over here where you can see the measurement area, you can define colors and all that good stuff. So this one window or this one zone that I've defined over here is going to detect temperatures above 50 Fahrenheit, right? Similarly, I have something over here for some below 50 Fahrenheit, which would be this zone right here. And then I have something for within a range, which is actually corresponding to this zone. And again, it's down to the pixel and it's detecting the thermal range. I have specified between 40 Fahrenheit and 120 Fahrenheit. Again, the comparison is within the range. Outside of range, same thing. You define your zone, and then you define the range that you're looking for, and that's going to be the thermal range and outside of range. And lastly, the percentage trigger. So the percentage trigger over here, instead of going down to 1 pixel, I'm actually going down to the percentage value, and I'm saying that, okay, if 5% of the hottest pixels are detected over here above 50 Fahrenheit, then I want to treat that as an event. Okay, so depending on the application, you can actually say, okay, 5%, 10%, 50%. It really comes down to what you're trying to capture. And again, the versatility of the options that are available with just the thermal detection. You can do per pixel, you can do thermal ranges, and I right now have 5 of these regions set up, or 5 of these zones. with this camera, with a thermal radiometry camera, you can do up to 20 zones. So just the other day, I was, sorry.
So yeah, I want to add something there. So think about that: 20 different zones, cameras strategically located on an oil and gas site that might be an unmanned site that you're looking at flare stacks, tank levels, even doing perimeter protection, doing all of those different things. One camera can do most of that on a small site. That's the value and what makes MOBOTIX so valuable, specifically in that industry. And we are very tight on time. I do want to be very cautious of the time and respectful of the time. So JP, just real quickly, two things on this. So how easy is it to set up those boxes, right?
Oh.
And then secondly, the magic behind this is not just capturing this, but the alerting, right? How is that different, or is it different than a regular optical?
Oh, so let's start with the window, the region. So let's say I'm looking at this profile over here, this zone, and I don't like this area. I want to make it larger or smaller. It's simply going to the live view of the camera, and you hit the shift key on your keyboard, you left click, you release the shift key, and then you click anywhere within the region or within the view of what you're trying to cover to define the zone.
Cool.
You come back to this window, it's set rectangle, and that is your new zone. So it is as simple as that to do it. This is just timed out for a second because didn't do it fast enough. But if you hit add rectangle, your zone can quickly be added.
So it's like setting up a video motion window box.
It is exactly like setting up a video motion window box, an exposure window box, an activity sensor window box. It's no different. That's the exact same process. Now, from an alerting perspective, within the camera itself, you have the ability to send out an email notification with a snapshot of the live view. You have the ability to include the actual temperature. So, for instance, if you're trying to, let's say, push out what the temperature was detected, and I'm just going to show that over here as a display. Second. So if you look at my live screen right now, these are the current temperatures that are corresponding to the values for the different zones. Now, each one of these temperature values can be included in the email by simply adding this one particular standard variable, and we have multiple variables. Another variable that I added over here was the actual X and Y coordinate of the pixel that is being detected with the hottest temperature, right? So you have the ability to do that also. But in addition to emails, the camera can play sounds. The camera can upload images to an FTP website. The camera can also, if connected to a SIP PBX, can make a phone call. So I mean, the options are endless. From an alerting perspective, I want to show you guys our newest platform, which is actually the MOBOTIX Hub. And over here, we have actually set up different types of alerts to come in. So if the alert is for outside of a range, or if the alert is, let's say, for above a certain temperature, it directly comes into the hub. And from here, within our alarm manager, you can actually pull up the event, or you can pull up the alarm, and you can review from here directly that, okay, this is what's going on for this event. So again, very, very powerful for industrial applications, especially when it's coupled and added into the MOBOTIX Hub. If your definitions are set up correctly for temperature detection, you can actually pull them into the hub and use the alarms from there. Of course, with our management center or software also, that is still doable. But just with the hub, the ability to do this is much, much more easier, and I feel it's a little more sophisticated. from an alarm handling perspective for an operator or whoever's going to be receiving that. Yeah.
Awesome. Well, I'm glad you brought up Hub. We don't have time to get into all of that today, but if anybody would like further information, further technical information on this, further sales assistance on this, please do not hesitate to reach out to us. I want to thank Michael Sunrise with Remote Monitoring. If you guys have questions for Michael, you can just get with me and I can get you in contact with him as well. So Michael, we appreciate you being on. Savannah, thank you for joining us. And JP, as always, our time is the most important thing we have to give. We appreciate you all sharing your time with us. And I hope you have a great day. If you have any questions, please feel free to respond to the webinar email that you get, and would be more than happy to answer any of them. So with that, thank you. Have a great day, and we'll see you next time. Thank you very much.
Thanks.